For decades, a rumor has haunted the oceans. Many believed the Philippine Trench was deeper than the Mariana. But something doesn't add up. Scientific data is scattered. Numbers contradict each other. Nothing adds up. So what's really happening on the floor of the Western Pacific? If you've ever trusted that claim, ask yourself, is it real evidence or just old measurements repeated until they felt like truth? Let's break it down. Most of the depth records come from surveys conducted decades ago, relying on just a handful of isolated points. But here's the problem. Different names, overlapping locations, and technical errors all conspire to create an illusion of extreme depth. And this is where it gets complicated. Modern sonar mapping shows the trench system is a tangled network, not a single monolithic drop. Depth varies dramatically. What seemed like certainty is actually chaos beneath the waves. So what do we actually know? The Mariana Trench still claims the title for the deepest point on Earth, but the story isn't as simple as the myth suggests. The truth is, it was never just about which trench is deeper. It's about the hidden complexity of our planet's oceans and the limits of our understanding. Comment 1 if you're ready to dive deeper into the truth. For years, people believed it was a single trench. A straight, deep cut plunging to the ocean floor. Clear, simple, but something doesn't add up. Maps shift. Depths fluctuate. The structure is chaotic. So what are we really looking at? If you've ever thought of it as just a trench, think again. Let's break it down. It's not a single entity. It's a fragmented system. Multiple segments, multiple layers, multiple depths. The deepest point lies near Mindanao, called the Emden Deep. But step away from that spot, and everything starts to diverge. But here's the problem. The trench segments don't connect neatly. They're bent, interrupted, influenced by underwater plateaus, seamounts, and overlapping tectonic boundaries. It's like trying to draw a straight line on a surface that's cracking apart. And this is where it gets complicated. Each segment behaves differently. Its own depth, its own tectonic pressure. Meaning, you cannot define the deepest point with a simple measurement. So what do we actually know? The myth promises a record. The reality is a chaotic system, hard to measure, hard to understand, and extremely dangerous. The truth is, this isn't just a story about depth. It's a tectonic frontier that could collapse at any moment. Comment 1 if you're beginning to doubt. Comment 0 if you still believe the legend. For decades, people thought measuring the Philippine Trench was simple. One measurement, one number, one conclusion. But something doesn't add up. Most of the data came from single-beam echo sounders recording only a single point on the ocean floor. If that point missed the deepest spot, the result could be off by hundreds of meters. So what's really going on? Take a closer look. Depth isn't just about location. It's also affected by the speed of sound in water shifting with temperature, salinity, and pressure. A tiny error could render the data inconsistent and hard to trust. Let's break it down. Most old maps didn't use multi-beam sonar. Multi-beam systems scan entire areas, generating detailed 3D images of the seafloor. Single beam? It's like throwing a dart in the dark. You might hit the target, or you might not. But here's the problem. There's no comprehensive sonar map covering the entire Philippine Trench. Each measurement stands isolated, decades apart, forming a messy patchwork. Old numbers linger, creating confusion. And this is where it gets complicated. Even when a depth is correctly measured, the different names Emden Deep, Mindanao Deep, Galathea Deep make multiple readings appear as separate records. The reality isn't a single deepest trench. It's a fragmented system, scattered, hard to define, and difficult to compare. So what do we actually know? The truth is, it's not that we've never measured the depths. It's that the true depths remain obscured by errors, outdated methods, and complex environmental conditions, a still incomplete picture of the deep ocean. For decades, the Philippine Trench has carried record-breaking numbers. A massive hole, a mysterious location, a legend passed from one report to the next. But something doesn't add up. The origin of these figures traces back to 1927, when the German ship Emden recorded a depth of roughly 10,400 meters, an astonishing number for its time. By 1945 and 1951, subsequent surveys reported around 10,500 meters, reinforcing the belief that this was one of the deepest points on Earth. So what's really going on? Let's examine the data. Some later reports claimed depths exceeding 10,800 meters deeper than the Mariana Trench itself. But analysis revealed these discrepancies arose from technical errors, miscalibrated equipment, incorrect assumptions about the speed of sound in water. A single misread measurement could ripple through reports and become a fake record. But here's the complication. Naming inconsistencies. Emden Deep, Mindanao Deep, Galathea Deep have multiplied the measurements. A single deep point appears under multiple names, creating overlapping records in books, papers, and online databases. And this is where it gets complicated. These so-called records do not prove that the Philippine Trench surpasses Mariana. They are evidence of messy data, duplicated names, and the limits of early measurement technology. The trench was never the absolute champion of depth. So what do we actually know? The truth is, it's not the numbers themselves that make the trench dangerous. It's the reality of a fragmented system, complex geology, and lurking tectonic hazards details the legend never told you. For decades, the Philippine Trench has been shrouded in controversial, record-breaking data. A persistent legend. An unverified mystery. But does the old data really hold up? In 2021, explorer Victor Vescovo descended into Emden Deep, reaching depths around 10,400 meters, almost identical to measurements taken back in the 1920s through 1950s. This modern confirmation seemed to settle long-standing doubts about claims that the trench surpassed Mariana. But look closer. It's not just the deep seabed. Plastic debris drifts, even in the ocean's most extreme depth. A lone teddy bear floats amid crushing pressures. A stark reminder, human impact has reached places few have ever dared to explore. And here's where it gets profound. The truth is not just numbers or legends. It's a warning about humanity's effect on the environment, even in regions thought completely isolated. The deepest reaches are no longer a purely mysterious frontier. They are living evidence of the eerie connection between humans and the global ecosystem. So, what do we actually know? This modern verification links classic surveys with today's reality. It shows that, while the trench doesn't surpass Mariana, both geological hazards and pollution remain very real threats. The legend promised extraordinary depths. The reality warns us, danger lies just beneath the surface, where human debris and tectonic pressure coexist in a silent, crushing world. For years, people wondered why the Philippine Trench appeared as a colossal chasm in the ocean. A dramatic, towering abyss. A natural marvel. But something doesn't add up. No deep hole forms out of nothing. So, what's really going on? Look all the way down. This is a subduction zone where the Philippine Sea Plate slowly dives beneath the Philippines. And this process is far from quiet. It warps the seafloor, fractures rock, and bends the oceanic crust, creating the spectacular depths explorers have recorded over decades. But here's the problem. The trench is not a straight line. It's a living system, changing along its length, influenced by friction, seafloor structure, and neighboring plates. Layers of rock and sediment are constantly crushed and folded like a massive geological engine running under unimaginable pressure. And it gets even more complicated. This location sits within the Pacific Ring of Fire. Seismic hazards lurk at every turn. Every tectonic movement is a potential strike, capable of triggering earthquakes and tsunamis along the Philippine coast. The trench's depth isn't just a number. It's the imprint of Earth's colossal forces, built over millions of years, forces humanity has only begun to understand. So, what do we actually know? The truth is, the Philippine Trench was never just a record-breaking abyss. It's never been about measuring the deepest point. It is a living, dynamic collision zone, a silent, deadly geological machine operating beneath the feet of millions of coastal residents every single day. Many believe that knowing the depth of the Philippine Trench is enough to gauge its danger. A single number. A simple metric. But something doesn't add up. One measurement can't tell the whole story. So, what's the real risk? This trench sits directly above a subduction zone where tectonic plates are moving every single day. The result? 3 primary types of earthquakes can strike. Megathrust, catastrophically powerful. Intraslab, occurring deep within the subducting plate. Outer rise, caused by the bending of the oceanic plate before it dives. Each type originates through a different mechanism. And even if 2 earthquakes share the same magnitude, the consequences on coastal communities can be dramatically different. But here's the problem. For scientists, predicting an earthquake isn't just about the Richter scale. The rupture mechanism, depth, and the exact location of stress accumulation dictate both the shaking and tsunami potential. A 7.6 magnitude quake can trigger a massive wave or barely rattle the shoreline. It all depends on where and how the plate breaks. And this is where it gets complicated. Different segments of the trench accumulate stress at different rates. Some areas are primed for a megathrust, while others generate intraslab events that still jolt coastal cities. It's a fragmented geological machine, silent but extremely dangerous, where every movement carries a hidden, catastrophic risk. So what do we actually need to understand? The truth is, the same magnitude does not equal the same disaster. The threat of the Philippine Trench isn't hypothetical. It's a dynamic chain of geological mechanisms, where each earthquake has the power to change the fate of millions of coastal residents. Many believe that every major earthquake near the Philippine Trench will trigger a devastating tsunami, a catastrophic wave, total destruction. But that's not entirely true. Take the 2012 event as an example. A magnitude 7.6 earthquake struck near the trench. At first, both the public and experts feared a colossal tsunami would sweep across the coastlines. But here's the twist. It was an intra-slab earthquake originating deep within the subducting plate, not a surface-level megathrust that typically produces massive waves. The shaking was strong, but the energy reaching the ocean's surface was limited. The resulting tsunami? Just gentle ripples. No catastrophic damage. So what's really going on? This shows that predicting earthquake consequences isn't straightforward. The same magnitude can produce completely different effects depending on the mechanism, depth, and exact location. Risk maps that rely solely on magnitude? Misleading at best. To truly assess tsunami risk, scientists need to understand how each earthquake occurs and where it strikes. And it gets even more complicated. A surface quake along this trench could unleash a giant tsunami, while a deep earthquake barely moves the water. No one can predict every single event with certainty. So what do we actually know? The truth is, the danger doesn't lie in the Richter number. It lies in the trench's complex geological mechanisms. The 2012 earthquake was proof, same magnitude, but nature chose the less dangerous outcome. It's a stark reminder that the Philippine Trench remains a geological time bomb, where every shift hides unpredictable risks. For years, people believed the Philippine Trench was just a simple, stable rift beneath the ocean floor. A straight line, a quiet abyss. But that's not true. Take a closer look at Benham Rise, a massive underwater plateau east of the Philippines. When this geological giant collides with the trench, it's far from a passive obstacle. Studies reveal that Benham Rise bends the trench, creating fragmented sections and altering depth across different regions. So what does this mean? A trench that was already complex suddenly becomes unpredictable. Tsunamis and earthquakes don't just depend on magnitude or plate location. They're influenced by these geological kinks. Even minor shifts can redirect plate movement, forming hidden pressure points where earthquakes and landslides are more likely. But here's the problem. The trench system is no longer uniform. An earthquake along a bent section can have drastically different consequences than one along a straight segment. Even predictions based on modern geological models struggle to account for Benham Rise's interference in this game. And this is where it gets complicated. Viewed from north to south, Benham Rise acts like a chaotic hotspot on the geological map. Every calculation of depth, seismic energy, and tsunami risk must now factor in this unpredictable variable. So what do we actually know? The truth is, the Philippine Trench isn't just a trench. It's a living, deforming system where Benham Rise amplifies hidden risks and makes predicting natural disasters far more difficult than anyone once imagined. For years, many believed the Philippine Trench was just a myth about depth, a tale of an abyss, a story of extremes. But here's the problem. The reality paints a very different picture. The trench isn't the deepest in the world, but it's a highly complex geological system, primed for megathrust earthquakes and tsunamis. Continuous deformations, fragmented sections, and relentless pressure from the surrounding plates make it a tectonic time bomb just offshore of densely populated areas. And this is where it gets complicated. Modern scientific data shows that even a small shift in this region can trigger unpredictable consequences. Communities, scientists, and disaster agencies must monitor the trench constantly, update geological maps, and prepare contingency plans for scenarios that could unfold at any moment. So what do we actually know? The truth is, the real danger far exceeds any legend. It's not about breaking depth records or claiming a title. It's about risks that directly threaten people living near the coast. If you care about community safety and natural disasters, ask yourself this: what seems like business at the bottom of the sea can impact our daily lives in ways we barely imagine. Comment 1 if you think the Philippine Trench is a threat we should take seriously.